Hi everyone, my name is Lexi Schade and I am a senior at Monroe High School, and today I will be doing a very simple demonstration of Newton's third law of motion using a Starbucks cup and my nightstand. Now, before we get started, I think it's important that we define the law and maybe simplify it a little bit so it's not so wordy. Newton's third law of motion states that for every action, or force, as we are going to call it, in nature, there is an equal and opposite reaction that occurs. Now, let's go back to what I said before about every action being a force. If you were to push someone, which isn't exactly the nicest thing to do, but it's an easy example, you would say that the action that you did was, I pushed someone over. What you're really doing when you push someone is you're applying a force to them, which causes them to fall over. So your action has a reaction. That's basically what this law is talking about. That's a very basic example with no calculations. The action of pushing someone over is actually the force that you're using to push someone over. So it's not just, I did this, it's this happened because of what I did. The because in this case is pushing someone over. Now, let's talk about a few forces that are acting on this cup as I push it across my nightstand. First off, we have the force of gravity, which is consistent for the entire time I'm pushing this cup. The force of gravity is simply the Earth's gravity acting on the cup, and it is moving in what would be the downward direction. In a little bit, I will draw what is called a free body diagram to display all of the forces on the cup. But for now, let's keep going over the forces that are acting on the cup. The next force is normal force, which is simply the force that opposes the force of gravity. So if the force of gravity is heading in the downwards direction, as it is in this video, that can also be called the negative direction, as we will see in a minute, the normal force is acting in the upwards direction, or the positive direction. Next, we have the applied force. Applied force is shown in the direction that the object is moving, which is shown by the arrow that you see on screen. As you can see, it's currently pointing to the right, and now the arrow is pointing to the left. This is because the direction of the object changed. The applied force is always the same direction as the motion of the object. That's an easy way to remember it. The fourth and last force that we have to talk about today is the force of friction, or the opposing force. Just like how the normal force opposes whatever direction the force of gravity is going in, the force of friction opposes whichever direction the applied force is going in. So if the applied force is pointing in the right direction, the force of friction will be pointing in the left direction, and vice versa. Now what you see is a sketch of a very basic free body diagram that I mentioned earlier. There are a few things to notice on this free body diagram. First of all, the title says Free Body Diagram for Objects in Motion. That is important because an object that was stationary would not have a free body diagram that looks like this. The free body diagram for a stationary object would not have the applied force or force of friction vectors because the object is not moving. The next thing to notice in this picture are the X and Y labels. Remember how earlier I was talking about how motion can be represented in the positive or in the negative direction? This is what I'm referring to. Here, we have a picture of a simple coordinate grid with the X and Y axes labeled. As the numbers increase, the direction is positive, and as the numbers decrease and go into the negatives, the direction is negative. Now, when you are solving problems, you can choose the direction of motion that you want to use, as long as you're staying consistent. So if I choose right to be my positive direction, as it would be the positive X direction, as shown on this coordinate grid, then the left would be my negative direction, or the negative X direction. This applies to the applied force and opposing force vectors that we talked about earlier. This also applies to the positive and negative Y axes, which would affect the force of gravity and the normal force of an object. Now, let's quickly go over the equations that you would use for Newton's third law of motion. These equations state that force 1, or mass times acceleration, as we know from Newton's second law, F equals ma, is equal to the negative value of force 2, or negative mass times acceleration. This is explaining that every action, or force 1, has an equal and opposite reaction, as you can see with the equals negative F2. So, how exactly does that apply to the scenario that we were observing earlier? Well, the action, or force 1, was pushing the Starbucks cup across the table. And the equal and opposite reaction was the friction of the table pushing back on the cup. And there you have it, a very simple demonstration of Newton's third law of motion using a Starbucks cup.